Okay, this is part 3 of our test on quadratic functions. In this video we will focus on solving quadratic inequalities that have the y in them. Alright, in other words, these are the ones where we will be shading either inside a parabola or outside of the parabola. Alright, this is different than what we did on the previous inequalities. There was no y, so we were graphing number line graphs like these and putting our answers in interval notation. There was no shading. But when there's a y involved, like this, that's when you're shading. Okay, let's go ahead and graph this parabola. I'm just going to leave it just like this and put it straight into my TI-30XS multi-view. You hit your table button. Alright, x plus 3 squared minus 2. So we have x plus 3 squared minus 2. Let's check it one more time. Okay, let's take a look. Wow, there's some big numbers. Let me get to where things start to fit. Okay, negative 6 comma 7 is the first number that fits. Okay, negative 6 comma 7. And then we've got 2, negative 1. So next is 2, and next is negative 1. And then we've got negative 2, negative 1, positive 2. So we've got negative 2, negative 1, positive 2. See how it's coming back mirror image style? So you know the next one's going to be 7. Alright, 0 comma 7. And oh, look how smart we are. Okay, once you see your parabola, go ahead and graph it. Alright, the parabola represents where the y values are equal to the function. Alright, these are the y values that are right on the parabola. Now, this inequality is asking where are the y values less than the parabola. In other words, what y values are below the parabola. So we don't want the y values that are on the parabola, so we will show those values, these border values, with a dotted line. So anytime it's just less than or just greater than, make that border a dotted line to show that they're not included in the solution. If we wanted y values that were less than or equal to the parabola, we would make the parabola solid to include that border. Okay, anyway, once you establish that, the solutions are either going to be inside the parabola or outside the parabola. But to figure that out, you have to think above or below. Alright, at least that's one way to do it. Looking at this less than sign, I'm thinking below. We want the y values below the parabola. So this will work if you look at the vertex. And if we want the values that are below the parabola, start shading below the vertex. Alright, below the vertex is down here. Alright, once you've shaded a little swatch below the vertex, then keep going, alright, because you have now discovered which part of this picture you need to shade in. Alright, below the vertex is below the parabola is this area outside. So go crazy and start shading this in. And there you go. This is your solution set. Now for some students, the whole above below thing is very tricky, and they wind up getting the wrong answer 50% of the time. So for those students, I have another method called the test value method, and all you have to do is pick one test value and substitute it in to the inequality and see if it makes a true statement. If it makes a true statement, that means it is a solution. and that means all of its brothers and sisters in that zone are also solutions. If it's not a solution, that means none of its brothers and sisters in that zone are solutions. Okay, and a convenient value to use is 0, 0. So let's see, let's do this. So let's use 0, 0 as a test value. Alright, test value. So that means x is 0 and y is 0 for this point. So if I substitute that into the inequality, that becomes 0 is less than 0 plus 3 squared minus 2. Let's see if this is a true statement. Alright, so this is going to become 0 is less than, well, 0 plus 3 is just 3 squared minus 2. Okay, and that gives us 0 is less than 9 minus 2. But that's just 0 is less than 9 minus 2 is 7. Is this a true statement? Why, yes it is. Which means 0, 0 is a solution, which means all of the other brothers and sisters that are in the outside part of the graph are also solutions. So since this made a true statement, this was a solution, we shade in all the points that are in the same family, all the points that are on the outside. If this had been a no, that would have meant that 0, 0 is not a solution. So none of the outside points would be solutions, which would mean that the inside points must be solutions, and I would have shaded the inside part. So that's how you could use the test value method. Alright, so some students like to use both methods and make sure they're getting the same answer by both methods. Then they're double sure. So you do what makes you happy. Alright, let's look at number 12 in the same light. First we must graph this parabola. Alright, I'm going to scroll up until it goes off the grid. Oh, there it is right there. Okay, negative 2, 5 is up first. Leg out, leg out. Negative 2, 5. And then we have negative 1, 0. And 0, negative 3. And then we have negative 4, negative 3, 0. Okay, negative 4, negative 3, 0. So you see the pattern is going back again. So we know the next point is going to be 4, 5, but you can check it if you're nervous. But you needn't have worried. Alright, now go ahead and draw this parabola. Alright, this time we draw the parabola as a solid line because we want to include the border. We want to know where the y values are greater than or equal to the parabola. Okay? Equal to the parabola means the parabola itself. So we'll include that by making it solid. Now, using the above-below method, of shading, greater than or equal to, does that sound like above or below to you? Yeah, greater than is above the parabola. Alright, it'll be easier to see if you look at the vertex first and then say, okay, I'm going to shade above this vertex. Okay, above the vertex would be all up in here. Okay, you feel me? And then once you shade in a little part that's above the vertex, then it's clear that you need to shade in everything in this region. Okay, so this is the solution set for number 12. Plain and simple. Now once again, if you were uncomfortable with the above-below method, or if you just wanted to double check with another method, use the test value method. And again, I like to use the point 0, 0 as my test value because it just makes the calculations easier. So if I substitute this into the x's and y's, well, let's see if it makes a true statement or not. So this would become 0 is greater than or equal to 0 squared minus 2 times 0 minus 3. Okay, but this would become 0 is greater than or equal to, well, 0 squared is just 0, and 2 times 0 is just 0. Okay, and all these zeros don't really matter when you're adding and subtracting. So this is going to quickly become 0 is greater than or equal to negative 3. Alright, because these zeros, you could just erase them. So 0 is greater than or equal to negative 3. Is this a true statement? Yes or no? Yes, 0 is greater than all negative numbers. So that's a true statement. That means this origin is a solution. That means all of its brothers and sisters in the interior of this parabola are also solutions. So we clearly shaded the right area. If this had been a no, that would have meant that this origin is not a solution, which would mean that none of the interior points are solutions, which would mean that the outer points must be solutions, and we would shade those instead. Alright, that's it for number 12. What's next? Alright, number 13 is clearly a word problem, so I'm going to zoom out so we can handle it. A model rocket is launched from the roof of a building. Its flight path is modeled by this equation, where h is the height of the rocket above the ground in meters, keep track of the units, and t is the time after the launch in seconds. So, first question, when will the rocket reach its maximum height after launching? Alright, I'm focusing in on some keywords here. The first one is maximum height. Okay, as soon as I hear that we're talking about maximum height, I know that we are talking about the vertex. Okay, we're talking about this point right here. Alright, this is the point of the maximum height, and I know that that is the vertex of my parabola. Okay, so this is supposed to be the building. Pardon my drawing like a 3-year-old. But yeah, so this is a rocket launched from a building. This is the flight path. It's making a parabola. We need to find the vertex for this question. Now, we know that to find the vertex of a parabola that's written out in standard form, you know, we're going to be finding the x comma y, which in this case, instead of x, they're giving us a t for time, and instead of y, they're giving us a h for height. Okay, so fine. So if we want to find t, alright, which is the x value of the vertex, that's going to be opposite of b over 2a. So let's do that. Alright, t you know, of the vertex is going to be opposite of b, so negative 30. Well, maybe I'll just write down the formula first. Opposite of b over 2a. So that's going to be negative 30 over, and a is negative 5, so 2a is negative 10. Okay, so that's going to give us t equals negative divided by negative is a positive, and 30 divided by 10 is 3. Okay, so that tells us the x coordinate of the vertex. So we switch back to yellow. So this vertex is going to be 3 comma something. Alright, and this is meters. Alright, 3 meters. I mean, no, t is time, so 3 seconds. Alright, silly me, silly me. Alright, now let's find the y-coordinate of the vertex, the height that goes with this. To do that, I'm just going to use my TI-30XS multi-view, and essentially I'm plugging 3 in for time. Only I'm going to use the table feature. So negative 5x squared plus 30x. Okay, so negative 5x squared plus 30x, and then what was it? Plus 10. Okay. Now, we want to see what's happening at a time of 3 seconds, which will be an x value of 3 for us. So might as well start at 3. So at 3 seconds, we're at a height of 55 meters. Okay, I keep meaning to go back here. So 55 meters. So this is the vertex. All right. At its highest point, this rocket is 55 meters above the ground, and that happens at 3 seconds after launch. So now that we've found all that, let's look back and see how many questions we just basically answered. Okay, so when will the rocket reach its maximum height? Well, like I said, 3 seconds after launch. Okay, so we can just write that down. 3 seconds after launch. What is the maximum height of the rocket? Well, the vertex is 3, 55, so 55 meters is the maximum height. Okay, so that's it for that. Now, when will the rocket hit the ground? Alright, well, when they give you the ground, hitting the ground, that is a way of saying that the height is equal to 0. Okay? So all we have to do is set the height equal to 0 and see what happens. Alright, so fine. We're talking about hitting the ground. Let me bring my formula with me. Okay, we'll do our calculations underground. Okay, so the height will be 0 right here, okay, at the ground. So if we let the height be 0, then we can find what time that happens. Okay, so let's do that. If the height is 0, then that means we have 0 equals negative 5t squared plus 30t plus 10. Alright, so we just need to solve for time. How are we going to do that? Let's use the quadratic formula. So we know that what we have here is we have a equals negative 5, and b is 30, and c is 10. So let's solve this by the quadratic formula. First, let's go ahead and define the discriminant. I'm talking about b squared minus 4ac. Okay, so that's going to give us b squared. So that's 30 squared minus 4 times negative 5 times 10. Okay, let's see what that is. Alright, there you go. So the discriminant is 1,100. Okay, so that's 1,100. Okay, so now we can go ahead with the rest of the quadratic formula. Okay, we're using t's, so I'll go ahead and use t's. I use using the right color now. So we'll do the opposite of b. Alright, b is 30, so that makes this negative 30 plus or minus the square root. Alright, b squared minus 4ac, we already calculated that, all over 2a. A is negative 5, so 2a is negative 10. Alright, so if we calculate this, this will give us the time. It'll actually give us two different times because of the plus or minus. So we need to do two separate calculations. Alright, we need to do one calculation with a plus and one calculation with a minus. Alright, that will give us the two different times. So I always do the plus first. Fraction mode, negative 30 plus radical 1100 over negative 10. Okay, that is negative 0.32 seconds. Alright, negative 0.32. What am I writing? Alright, seconds, and we're talking about time here. Okay, let's do the minus version now. Alright, now I could type it in again with a minus, but if you want, I could just come back here, highlight this, and then scoot my way over to that negative sign. Well, right now it's a plus sign. Now I could just make it a minus sign and hit enter. So that's 6.32, rounding up. Seconds. Now, only one of these times makes sense in the context of a problem. Okay, is it possible that the rocket hits the ground at negative 0.32 seconds? Alright, in other words, the rocket hits the ground 0.32 seconds before it is launched. No. That value is what you call extraneous, so we're just going to throw that one out. You can't have a negative time. Okay, we don't have a time machine. So that means the only viable solution is this, alright, 6.32 seconds. Must be when it hits the ground. Okay, so let's go ahead and write that down and then think about it one more second. Okay, so when will the rocket hit the ground? After launching? Well, at a time of 6.32 seconds. Okay, so that is the final answer there for number 13. But let's just take one more look at the picture. 6.32 seconds. Okay, so understand the path. What happened was we started here at time 0. Okay, so that's here at the beginning. And then here 3 seconds later we're at the highest point. But then at a time of 6.32 seconds, that's when we're finally hitting the ground. Alright, so 3 seconds and 6.32 seconds. Alright, that is it for this video. This is long enough, and we've reached the end of the page. So this is a convenient place to stop. We will pick up with some review questions for our fourth and final part of this test. Looks like we're going to practice factoring, do something with these imaginary numbers to a power, and some other quadratic stuff. Okay, I will see you on the next video.